All right, thank you. So this room is for the fuser in the cloud. And I can't ever say that word, forget it. If you were looking for the demo, it's in the other room. Despite the slides that were up here a second ago, I am not presenting on that. So if your last chance to leave now, if you don't want to hear about the fuser. All right, so quick show of hands, who's actually sat through a fuser presentation before? Okay, so good chunk, but so there is some redundant information for you people. We presented at Swift and some background on what exactly the fuser is, what it does for you. And so we'll talk some about that, and then we'll spend the last part of the session talking about what we're doing, this fuser in the cloud pilot, and where we're going with that. So we have a little bit of extra time, even though we are starting just a little bit late. I actually thought this was an hour session, but we have an hour and 15 minutes. So if you have a question, just throw your hand up, and we'll try not to get too off track, but we do have time to kind of mix in some questions as needed. And then we have technical experts up here, and Brian, and another expert working his way out of the room for some reason. That hey, Al, you know your name's up on that, right? Yeah. All right. So fuser overview. So we talk a little bit about some of the swim sources that go into it. Even though the fuser on ATD-2, we consume more than just swim sources. We have direct airline feeds. We're integrated with the MITRE mobile app. We've done a number of things, but we're really focused on this presentation on what the fuser could do to general industry outside of ATD-2. So things that are a little more proprietary that you wouldn't necessarily have access to, they're not going to show up in these slides. What we are showing are things that anybody should be able to have access to through SWIM. All right. Talk about the fuser, the flight data. We'll talk about some of the processing that goes on, filtering rules, mediation logic, matching, things of that nature. And so if any of those particular areas interest you and you want to ask questions, you can either ask in here or grab me afterwards. Stick around at the end of the day for the open session and talk to myself, Brian, or one of the others on the ATD-2 team about it. And then again, fuser in the cloud. So this big wordy slide, I think Al actually put this together for me back at Swift, but SWIM has been put together by a lot of people. A lot of work has gone into it, so anybody that's worked on SWIM over the years, again, thank you. I'm a big fan of SWIM, a lot of great data. Even for any complaints you might have about it, before there was SWIM, it was really, really hard to get the data. So even though it might be some challenges to work with, you can do things now that you just couldn't do, in the past. But leveraging it, again, has some challenges. You've got the 3 T's. There's different data in all systems, and kind of learning the nuances of each of them can take some time. And on ATD-2, we've spent and invested a lot in trying to make this data usable to our system. It is the backbone of our system, and once we've had all this data, we've really taken it to another level of dealing with the analytics and how to put it in operational use. So if you make your way around to the other demonstrations, the other sessions today, I mean, you'll see a common thread, whether you're talking, about metering, whether you're talking analytics, there's this underlying thread that, the fuser is the backbone that's kind of at the core of a lot of these things. And, it's been a pretty heavy investment. So again, we're trying to find ways to transfer back to industry, and this is one of the initiatives, just trying to get portions of the fuser out there and information about what went into the fuser to help others. So all that wordiness kind of said another way is, there's lots of data, has a lot of value, but consuming it and working with it has a lot of challenges. So, if only there were a way to fuse it all. And so that's what we're here to talk about. All right, so, this whole angle thing is not working very well for me. Again, all this is said another way. I mean, with all this data, there's a lot of challenges, and you're trying to find ways to make the data actionable and operational information out of this data. So the solution to us really is been the fuser, to learn how to use the data, the right data at the right time. So, it's not just about, I can parse the XML. It's about getting the right pieces of information. Thank you very much. Getting the right pieces of information at the right time means you got to get, do you want TBFM, at a certain point in time? Do you want its flight plan? Do you want the TFMS flight plan? What ETA from what system do you want? What mediation locks do you have to apply to it? So all this is going on in the fuser, and we'll talk a little bit about it as we go through it. And another big thing is it's all backed by a well-defined model. I mean, you look at TFMS and you look at TBFM, and it's all XML, but working with different pieces of XML is a lot more complicated. In my opinion, TBFM is a little bit more difficult to work with than TFMS. And the fuser is a little more modeled off FIXM, but seriously flattened. So if you work with FIXM, it also has some nested levels that make it a little challenging as a developer in particular to work with, but we'll talk about that here a little more in a second. Why would you even want to use all these sources of data, though? I mean, if I'm sitting here telling you got all these challenges to pull data, well, you want to use it because it's just not in any one particular feed. TFMS has, the in-route pieces has CDM data in it, has good modeling of trajectories and stuff, but TBFM has its own modeling trajectories for other reasons. So why you would want to use it at a different time? You got metering, STAs and stuff coming out of TBFM, and then TTP and TFDM is going to come along. Now you got a whole new rich set of data that you're going to want to consider, but that data is not going to be in TFMS. It's not going to be in TBFM. And it will be ingesting from those other sites, but it still doesn't have every element is not in a TFDM feed. So if you want the complete picture gate to gate and all the elements and when you're going to use them, you got to go get it from multiple sources. So kind of brought this up a number of times. What is the fuser? I mean, fuser, it is a software, but it's also an architecture. It's made up of parsers. It's made up of a matching service. Inside the fuser itself, you've got pieces that do transformation, filtering. We call it updating, which is kind of added value stuff that's going on in the mediation logic. And then all this kind of flows out to our fuser databases so that we can do both near-term, next day, and long-term analysis on this stuff. All right, so this diagram, probably pretty hard to see from back there, but just notionally at the top is your feeds coming in. And as you work your way down, you work through some connector that's job is just simply to make the connection to swim and bring the data into your environment. And you work your way down from that, and you get into these parsers. And the parser's job is to take any complicated XML and make it into something that's more, I don't want to say user-friendly, but at least application-friendly for us. The TBFM schema has some areas that we got to dig some stuff out, and there's also where you might need to do some aggregation, which I'll talk about in a second. And then once it moves through these parsers, you kind of get from a more, sometimes the schemas are fine to work with, sometimes they just need some massaging. And so what comes out of these is a little easier to work with, and then you move into the matching services, and the matching, once you get past that, then you're into the fusion services. And the fuser is where it all gets brought together, and that filtering, updating, mediation logic all gets applied so that you get one feed, everything all kind of merged together, and in theory, nice, easier to work with than trying to deal with it with all these different sources. And at the very bottom of the diagram is just the data being blasted out to whether it's a Fuser client API, and I'll show different areas where the data goes. But any questions at this point? No, I'm kind of moving through these sections fast because I think people have probably heard this before. Maybe this is not, the area that you focused on that much. And if we get through fast enough, you can go next door and pick up on the ATD-2 demo if you're interested in that. So.
Yeah, Sean, do you want to answer any of the social Q&A stuff right now, or wait till the end?
Is it anything kind of relevant to where we're at in the discussion so far?
So just glance at the first one, because it gets into questions about the data mediation and flight matching, the different business rules that we're using to do that.
Let's hold on that because there are a couple slides that we can point them to, and we can, if that doesn't answer it, then we can open it up a little more.
Okay. The second one was asking if this is the first and only fuser in the NAS right now.
So I would, I don't know the answer to that. I would say that the idea of fusing is not unique to ATD-2. I mean, most organizations, if you're bringing the data in and into some sort of data lake or consolidated flight management system, you have some variation of a fuser going. And so I know, probably every company that works with the swim data or, airline data, their own data, has something going on. I think uniqueness of the fuser is just trying to do something a little bit more with a common goal in mind to get it out and have others be able to use with it and work with it. And we're looking for long-term homes, NASA in particular, whether it's an FAA organization that is interested in taking it on, or whether there could be some follow-on ATD-2, we don't know. But we're looking at solutions, and that'll come up in the fusing the cloud discussion. But I don't know the names of any other things that are doing the same thing, but again, I think conceptually it's probably happening at some level, just probably with different goals in mind. And I'll say that going back to the swim feeds too, I mean, anything that you might have a complaint about a particular swim feed, keep in mind, these are coming from systems that were designed, decades ago, and that data is coming out and being made available. It wasn't like there was some initiative back then that says, hey, when you design TFMS or ETMS, back when it was ETMS, it needs to be shared on this swim service for everybody. That wasn't kind of a mandate back then. So, what's in the data, what it looks like and all that, wasn't really meant for what it's being used for right now, but it's been made available and is valuable information. I'm sure, every program being asked to do it differently, if they knew back then, might have structured things a little differently. So, anything else at the moment that we'll check in like 10 or 15 minutes?
Yeah, we can check in a little bit later.
Okay. So if you have questions, again, keep them going on the conference IO. We'll pick them up. If you don't want to throw your hand up, that's fine. We'll do it that way. So talk a little bit more in depth about the data parsers. I mentioned it earlier. The data comes in, and this is kind of where the massaging of the XML, where it's can be a little more complex to deal with, and trying to make it, by the time it hits the fuser, it's usually flattened out. It's usually kind of any noise in the data is kind of cleaned up. Formats are standardized a little bit. Position data, things like that, can come in weird formats, so you're trying to deal with those kind of things. So, back, I want to talk about, we're dealing with the swim feeds. So, I mean, what's in these swim feeds that we really care about? For us, the primary ones we're using are listed up here, and TFM data, the flight data, is pretty core. I mean, if you're just getting started with swim and you haven't dealt with any feeds, and, if you're not looking at, I need surface positions moving around on an airport, and you're just trying to figure out, like, flight plans or how many flights landed, whatever, you should start with TFMS, in my opinion. It has the richest set of data. It's got data being ingested from the other systems, but it doesn't have everything. But, if you're only picking one, it's probably your best place to start right now. If you get to the point where, I want to see what's going on the surface, I want to be able to do more detections of movement area events, more precise off times like ATD-2 is doing. Then you want to get into the ASDX surface track data. You're trying to get to the point of, I want my release times. That's when you're getting into TBFM, the metering times. You get to when, if you're an airline or a CDM participant, I mean, if you're not, the TFDM terminal flight data, TFMS terminal flight data, it's probably not all the value, but that's where the EOBTs and the gates, the tail numbers are coming in. But what's going to come out, is not really going back out to everybody. That's intended more of an input for the people that can get the terminal flight data. If you're a CDM participant, you can get the EOBTs. If you're not a CDM participant, you're not getting the EOBTs back out. So that come to the TTP feed presentation, we'll talk about the privacy levels and whatnot later on today. We got our first defector going for the demo. I don't blame you. That's all right. So, SFTPS, we recently started ingesting this one. And again, each feed there is overlap. I mean, SFTPS is essentially ERAM if you haven't worked with it, but that data is feeding into TFMS, but not everything is showing up in TFMS. So we actually tapped into this recently to get like the datacom equipage. So as part of our phase 3 evaluation in the Metroplex at D10, it's proven to be helpful if they know that the flight is equipped with datacom, so they know if it's a good candidate to actually exercise the TOS operations on. We couldn't identify that information out of TFMS alone, so we tapped into SFTPS to get that data. So just again, point out like these are some of the overviews of what we in particular are pulling from these different feeds and what you may want to go get out of them if you're trying to pull a certain piece of information. Certainly not an exhaustive list by any means. You should understand though that, you know, I've kind of hit on it as I've been talking about, you know, SFTPS, ERAM data flows into TFMS. They're interconnected. I mean, they're not so siloed that this only gives you one set of data, this only gives you one set of data. You can find overlap in data and they kind of feed into each other in a lot of cases. So again, it's no one-stop shopping. There's some complementary stuff, and then there's added value stuff, and then there's just kind of segmented stuff. But this slide kind of gives you some of the details of kind of how they, you know, the inputs that are coming from each of the individual systems. All these slides will be posted, so if you kind of want to use this as a little background material and just kind of understanding a little bit more of the swim feeds and how they interconnect a little bit. And this slide is, you know, again, just kind of expanding out on kind of durations. You know, TFMS, you can get things 24 hours roughly in advance. You know, that's basically scheduled flight loads from the OAG will start showing up. So you start seeing flight plans where you get to something more like TBFM. You're not going to see anything till it's, you know, a file flight plan, which is usually an hour, maybe up to 2 hours pre-departure. And then you get to STUDS, you're not going to see anything on an ASDX until the flight's actually moving around. So they have different look-ahead times, different frequencies and whatnot that you can get a little information there. Any particular questions on the swim feeds themselves before we?
There was one question about any strong use case for airline consuming SFTPS data?
I would think most of the data that you would need is in TFMS. I think beyond that, you were probably, as an airline, probably input some of that information, so you probably know the overlap. So again, I haven't probably gone deep enough in the SFTPS to blanketly answer that question, but I would still default to stick with TFMS as much as you can. Josh? So can you expand on your comment on the source? What do you mean by when you say if you want to know the source?
Well, if you want to know, if you're trying to interact with ERAM, something there, then you need to go with ERAM's flight plan.
Okay.
Right? So TFMS's flight plan that it gets from ERAM is not necessarily ERAM flight plan.
And if there's a flight plan expert in the room, you can correct anything I'm about to say, but we've in our phase 3 operations, we were learning there are just all kinds of special rules with these flight plans that I didn't even dream existed, and we were trying to do what we thought was okay. If you're going to reroute a flight, you tell us to reroute it. We'll look for the flight plan to come back, and we were using TFMS, and we're finding that, you know, how it's input through ERAM could be quite a bit different, and even what comes back from TFMS doesn't always match, and so I'm not even going to pretend to know all the rules and the process that goes on to that, but, you know, there may be value in that if you want to get down to that level and understand, you know, what went in and the source of it. It's pretty rich data. I mean, there's a lot in there, but probably one of the less understood feeds so far because, you know, comparatively, it's one of the newer swim feeds that's been out there. So parsing data feeds, I think I've touched on this a number of times. I mean, we're transforming the XML. We're trying to convert it to something we can work with a little easier, but probably what I touched on a little bit is the aggregation piece. Like Studs, ASDX, TBFM does this. TFMS is a little different. I mean, you're getting batches, but you can get an update. Studs ASDX, for example, you're getting updates every second, but you're only getting the delta of what changed, and then every minute you're kind of getting a little bit more of a complete picture. So you can get the call sign, the full lat long, and other information, but in between that, you're just getting 1 second updates. This is a pretty extreme example, and I think this has actually been corrected. There used to be a time where you could even get to the point where you could get a latitude, longitude, and the latitude didn't change, but maybe the longitude shifted somehow. And you would actually, if you just trusted what was in the message by itself, you would end up maybe setting the latitude to 0, and then you're off in Africa or something, you know. So now, you know, so you have to have a little bit of logic, and you might want to do this with other fields that are in ASDX, but if you're trying to get a complete message of what's going on, you need to kind of carry information forward, and then you get to that 1 minute update and you get everything again, and then for the next minute you're getting 1 second updates where you're only getting what's changed. And it's similar to TBFM where you're getting only what's changed, and then every 15 minutes you get a full sync of everything. So just these are all things that our parsers are tracking, and things that you probably should be aware of when you're dealing with these feeds. Basic flow, we get it from our connector, bring it in, bring it through this processing engine, and then we're trying to basically flatten it out. You know, you see, in this case, this is the terminal flight data for us, TFMS. This is how the airlines are sending in. When they send in the EOBTs and stuff like this is what the format looks like, what we see. So it gets put into this FIXM format. You know, as a developer, I would see this and I'd get, you know, this, if you can imagine the XML nested here, you get this flight message, departure NAST, and position, stand, and time, and on down to actual time. You know, if I'm writing code for this, I gotta go flight. You know, if this departure NAST is not null, then I can get the departure position and time. If that's not null, I can get the stand time. If that's not null, I can, you know, so your code ends up being, you know, kind of verbose. You could write some utility methods to make it easier to work with, but we basically flatten it out and just say, hey, that maps to our actual off-block time. So once we're in the fuser code trying to mediate things, you know, it's just one field we're checking as opposed to this long nested structure. And this is true of a lot of the XML feeds and trying to work with them. So that's, in a nutshell, I mean, between the aggregation and just kind of making the XML more sensible, that's what most of the parsers are doing. And then they move to flight matching. So before we move to flight matching, any checking on any questions real quick?
There are a handful of questions, but I think you'll probably end up addressing them once we get to the flight matching and the actual fuser output. So we can.
Okay. So keep me honest if I don't. So time check. All right. So flight matching. So right now there's, and when we're moving to the fuser in the cloud, I'll talk about this a little more. But the flight matching, we have this concept of local matchers and global matchers and whatnot. So they're kind of integrated with our parsers, and the parsers will look to see, hey, do I know enough information just in my own little local parsing repository to know for sure what the global unique flight ID is? Because I just, you know, I got that ASDX message 1 second ago. It has the same call sign, same MODES, everything's the same about it, and I've already called the Goofy service. I have a Goofy global unique flight identifier, so I'm going to use the same one. If I see something completely new that I don't know, then I'm going to call the global Goofy service, which I'll show the flow in a little bit. But just jumping forward a little bit, we're kind of moving more towards let's move out that local matching, trying to imagine, you know, if someone other than us is going to use this, it's a little bit much to embrace and understand how to set it up. So now things will just move from the parsers through the Goofy service, which will handle both the local and this global matching concept I'm talking about, on into the fuser. So the flow becomes a little easier to understand and certainly easier to regression test. So the goal, though, is just to assign a global unique flight identifier to every message coming through. So, you know, if anything we can. There are some cases that there's just such sparse information and we have no information to begin with that we just basically have to categorize it as unknown. That would only be like in a clean start situation, and the first thing we got maybe was an ASDX message that basically didn't even have a call sign or a mode S in it. It was probably the most extreme case, but that's pretty rare. And the Goofy, the importance of it is this what links us across all these feeds. I mean, every feed has a unique identifier. TFMS has the flight ref, ERAM has an ERAM Goofy, you know, the ASDX has the track ID, TBFM has its own, but you know, some of the IDs recycle, so they're not meant to be global all time. They're global for, you know, whatever window that is. And so, I mean, track IDs only think go up to 9,999, I think, at each airport. So we're building a Goofy that is unique across all source feeds and, you know, in theory, across all time. Someone asked a question about the fuser. Is this the only one? And again, on the Goofy is not a unique idea to ATD-2. I'm not taking credit for it. It's been around the NAS and been talked about. Papers been written on it and everything. So, you know, how to identify a flight, even know how to represent that identifier has had a lot of discussion. And just the last caveat for the flight. I mean, a flight for us is gate to gate. It's, you know, the tracking of an aircraft is, the piece of metal is a little different than for us tracking a flight. You can have an aircraft associated and move to a different flight and all that stuff. So we have a whole different aircraft management for dealing with the pieces of metal versus, you know, a flight from departure to arrival. Kind of expanding on the flight matching when I'm showing the parsers and just a bunch of lines, but I mean the idea is that right now that goes into the parsers, and each parser has that line up to the Goofy service that if it needs to make that global call, that's what it's doing, but no message is going to leave that parser and move to the fuser without a Goofy attached to it. So by the time it hits the fuser's job becomes the updating and the mediation and the filtering. And this, well, I said earlier, I mean, the fuser is an architecture. It's even though we have a component that is named the fuser, you know, the fuser encompasses the matching and the parsers, and they all work together. So if I just started pumping all this data into the fuser without the matching service, a fuser is going to throw its hands up and just, hey, you're just giving me a bunch of data with no unique ID. I don't know how to basically fuse this information together. It's not, you know, going to just grow smarts and, you know, do matching, because it's relying on the Goofy service to actually have done that by the time it gets to it. But at DFW, I mean, we run right now for ATD-2 a fuser for DFW and a different fuser for Charlotte, just to be able to support operational flexibility. So if we need to make changes, you know, we're on different baselines right now of the ATD-2 software at Charlotte and DFW. So, but it's fully designed to run the whole NAS, and I say the full NAS up to, I have not ever tried to ingest like all of TACE and everything all at one time. I mean, there would clearly be a breaking point in the volume that we haven't dealt with, but as far as TFMS, TBFM, SFTPS, and ASDX, we can handle those. But, you know, as Josh and his team bring more and more data online, I mean, I've never tried to tackle 4.3 terabytes a day, so, you know, that would be a new challenge. So the basic flight matching approach here, you know, you get a flight, and it's going to come in, and you're going to ask that question. Let me back up. I mean, the basic concept is, rather than writing a bunch of rules, and we tried this years and years ago, where you say, you know, if this, else this, do this, you're a match to this. Well, you end up with so many logic cases that you could end up getting crossed up, and depending on the order you did it, you could end up in a different answer sometimes. So the approach is actually come up with a possible universe, and then you filter it down until there's only one guy left. So, you know, in a basic nutshell, you say, give me every other flight that has the same call sign that we know about, and that's kind of your starting point. And then you can start looking at departure arrival airports, departure arrival times, and other rules on that. But we don't go with the approach to try to fit it to exact one flight. It's, you start throwing everything out that can't be a match. And if you're left with 2 or 3, then you go through resolve and come up with the best match possible on what's left. And this has kind of reduced the amount of code quite a bit too. I mean, the old days of, you know, a lot of matching rules was just, it was it was brittle before we rewrote it for all this stuff. So a lot of lessons learned, and but you go, you find a match. If you got it, then you reuse it. If you don't, a new goofy gets created, and that one becomes, you know, available, and that information, and we're storing all this information, this matching service. There's probably 20 or so key identifying fields, which is everything from your call sign, mode S, tail, to arrival, departure, airport, to a variety of times. All these things are kind of in consideration that we're looking at in the matching services. Quick flight matching example. In this one, as you kind of work your way down, you can see on the far right column, I mean, it's call sign, origin, destination, and then the numbers on the end are basically day, month, year, and then dot, hour, minute is the 1900 in that first example. And then the .000 is just a number that is just an integer that every minute we reset it. But so if we create 1,000 flights in a minute, you would see, you know, that number on the end get up to 1,000. So you know that many got created during that minute, and then we just move on to. So that's kind of keeping our uniqueness, and so we don't rely on any sequence number that resets or anything like that. It's kind of we found this kind of helps in kind of troubleshooting, and it works in our environment. There's probably cases where, and there are cases like a diversion. Well, we don't change the goofy, but if a flight diverts, you know, you actually are going to a different airport than what the goofy actually says. So there are some oddities that you have to deal with, but it still kind of made sense in our world just for debugging to kind of have more of a logical name rather than just a straight up UUID or something. But this one you kind of see, you go down, you got the scheduled flight plan, file flight plan, amended flight plan. You're getting it from multiple sources, from TFMS, SFTPS, and TBFM, and you're working your way down, and it goes through the matching service, and it identifies it and says, oh, it's the same call sign, same origin, destination, times are close enough, you know, it's got to be the same flight, and you keep going. Then you get down to the fifth row there, and you kind of the highlight areas, you notice, hey, it did have the same call sign, did have the same arrival, departure, airport, but you know, you look close enough that departure is actually for the next day. And so that's a sign that says, hey, this is not the same flight. We need to create a new goofy. So fairly simple example, but you know, it's you gotta account for a lot of things, and you know, this one is a little easier because it's a complete day shift. Sometimes the flight is going to get delayed just by an hour, but it's still the same flight. You know, so you got to be careful, like, you know, on your thresholds, and there's been a lot of lessons learned to come up with the right thresholds for us. We'll say we spent, you know, a good 90% of our effort is dealing with the little anomalies on the 10%. I mean, you could do pretty good matching just on origin, arrival, destination, and an IGTD, and you can trust the TFM ref ID is pretty good. I mean, there's a lot of starting points that get you pretty close, but you know, more feeds, you know, you get more anomalies, you know, putting things together, and we've spent, you know, all the rest of the time just dealing with, you know, cancellations, multiple flight plans. You know, it's been one in particular that comes up a lot. Sometimes you just get weird data, you know, and all this has to be accounted for. So part of the way we account for that is we've spent a pretty good amount of time building a pretty good regression test harness. So, I mean, the system's big, data is moving, everything's moving through pretty fast, but I mean, we're recording everything, and we have databases for a lot of stuff. And the regression tester basically takes all the stuff that we recorded and is able to pull the information for whatever case that we're looking at and feed it back through the matching, and it's going to reproduce the exact same result that it did live. And what we're able to do is fix the logic and then basically run it back through, and it, you know, once it's fixed, then it should produce a different answer. And then we're able to then change that recorded file that we're using to say, well, this is what should have happened. And then that now becomes our truth case for the next time. And you know, every time we fix one of these, we just build up another regression test case, save the data, fix the logic, fix the data, record it, and that gets saved into the code bases. You know, and there's well over 100 of these right now for different cases. And that's just kind of kept us. Jason Burke, who does a lot of work on this, he's not here with us, but he's our whack-a-mole expert, you know. So that's not actually him, but I mean, I could totally envision him because he sits right next to me and he's just over there beating on his desk half the time, like, you know, when he runs in these things. So I think that pretty well takes us through flight matching. So how are we doing over there, Brian?
Just a couple questions. You mentioned that it was pretty fast getting through all the data parsing and stuff. Do you have any numbers on the latency-wise on what type of delays we'd be dealing with?
So the last time we checked on from end to end, so from the time, so we record in the fuser itself in the databases, you could see the time that the source message said it was sent. We record the time that we received it. We record the time it got through our parsers. We record the time it got to the fuser, and we record the time it left the fuser. And the last time we aggregated this up, I mean, from the time we received the message in a parser to the time it went out, you know, it was somewhere between 200 and 400 milliseconds, usually under 200 milliseconds on average. There are times where we hit, you know, just a big spike in data where that might, you know, move into the upper hundreds of milliseconds, but it's stayed consistently under a second, which has kind of been our target to kind of keep up with that.
There's another question about the regression tests. If there's any plan we have to release those out to the public to help others with their matching problems.
So they're in the code base so we are working through trying to figure out how to make some of the code available. It's kind of a long process that we're going through at NASA, but so the test cases, well, can you take a note taker? Can you take an action item to follow up on making the regression test cases for the matcher available? Because we have them. I mean, the only reason I'm not just flat out saying yes is because I'm not sure that they're documented in a way that would help everybody right now. We can feed them in our framework, and they're kind of commented in as to what they are, but I think without some extra documentation, they probably are not that valuable to anybody at the moment to just release as is.
And then also, do you have a slide coming up talking about how we're storing data in the databases?
So I did not cover the databases today.
Okay. Well, then maybe a quick question was whether or not it'd be worthwhile to store the data in the airline's internal data warehouses and using a relational versus a flattened out database.
So we've gone kind of a hybrid where we go as flat as possible on our databases, but there is some serious redundancy in some of them. So like the position data, do have those split out to a separate table that can be linked in through but most the fuser databases are in a pretty flat structure. We also capture all the raw sources into tables, and we try to kind of line those up with the messages as they come in, so it kind of can be linked back to figure out what we got easier. But if we take a note to actually add a slide to the SWIFT material, because we have previous material on the databases and how they're laid out on both at SWIFT and previous ATD-2 demo series that do cover the databases in a little more detail. I favor the databases in a flat structure versus just kind of trying to ingest it into something like MongoDB or something that just takes the XML. Just mainly for performance and scalability has been a little tougher when I worked with those. We have put quite a bit of time into partitioning setup to make sure that they're fast to work with and usable and everything. So I don't know, there is a one size fits all for everybody, but for us, kind of a flattened as much structure with pretty good partitioning has worked out pretty well for us. But we do still archive all the raw stuff too. So if we ever have to go back and reprocess something, I mean, we have the XML messages, and we have to do it at times. We try to avoid it as much as possible. That's why we capture as much as we can into the databases. And if you make your way to the analytics tracks, you'll see there's also a lot of post-processing going on where people take that and really try to summarize it almost on a flight-by-flight basis, so that you're trying to find the first position hit, what was different information at different states and things like that. so that processing gets pretty wide, but it's pretty fast to access that data, and they've been able to do a lot of pretty cool trending stuff by accessing it that way. Anything else?
There's some more regarding the rules being used for flight matching and mediation, but it looks like you might be getting to that here in the next couple slides, maybe.
Yeah. So we'll move through. So now at this point, we've gone through, you've connected, you got swim data, you've decided which swim feeds you're gonna deal with, and you've gone through some parsers, you've got through the matching service, now you can send the data into the fuser. And so for all of ours, at that point, we're basically taking that flattened schema that I'm talking about that comes out of our parsers, and you're feeding that into the fuser, and this is where the fuser is gonna take it and really put it into the common fuser format and apply some rules and processing logic. I touched on it earlier. Our fuser is a common definition we're trying to use across the whole thing, and it is based on Fixum, but really, really flattened. So in Fixum, you might have a flight, arrival, runway, and an actual time element, kind of all nested down. For us, it's just arrival, runway, actual time. So I know it's incredibly verbose, our naming convention, but it's also somewhat self-documenting. If you're looking at the data in that field and it says it's an arrival, runway, actual time, well, it applies to arrival at the runway point, and it's considered an actual for us, and it's a time element, and that's kind of consistent throughout the whole. There's categories and the naming would include that, the resource type, and then a source type. So these are all pretty well broken out. Even down to timestamps are all pretty verbose. Whether it's source timestamp, fuser receive timestamp, and all that. So we do have a data dictionary, and all this is published on a website on the Fuser Industry Days. There's a link in this presentation that you can get all that. But the data dictionary itself, kind of will highlight any details that are missing, but the elements themselves are meant to be kind of self-documenting as much as possible.
There was actually another question about this too, on whether or not the data we're producing is interoperable with Fixum.
Not without an adapter. So I mean, we internally have a Fixum adapter, so you can go from Fixum to the fuser and vice versa. But I mean, you would need that adapter to kind of be interoperable with Fixum. So again, the data mappings, kind of breeze through this one. I mean, well, I'm not gonna breeze through it actually. We spend an immense amount of time on data mapping. I don't know, there's other things I'd like to talk about, but everybody seems to get stuck here. When you look at TFMS, TBFM, you just want some piece of information out of it. You got the JMSDDs, but you don't, it's still hard to navigate that data. So we spent a lot of time just trying to figure out, okay, if we're going to call this an aircraft type, where is the aircraft type in TFMS? Where is the aircraft type in TBFM? Which messages does it come in? At what level of the XML does it come in? And so we spent quite a bit of time, and I know this is pretty microscopic, but at that link at the bottom there, so the mappings that are up there, and the idea is, on the left, this is what the fuser is calling it, and on the columns over there, these are the kind of the nested level we found it in those source feeds. And like TFMS is the second one, actually has kind of a second layer of nesting. So as I said, the parsers kind of flatten some things out. So by the time we pull it out of the fuser, you took it something like the aircraft equipment suffix or the physical class, that if you want to know what the physical class was in TFMS, you can drill into that one more level to see all the messages that it came in and what level to find it there. But take some time to review it if you're working with swim feeds, because I mean, it's just, the nesting is deep and there's a lot of messages, and we spent a lot of time, and a lot of it was just digging through whatever documentation we could find, relying on subject matter experts, and then a lot of it is just lessons learned where, our first crack at this stuff, years and years ago wasn't correct, and, we learned through analysis and corrected it and updated the mappings, so. All right, so you get into the processing. Now you've gone through, you matched. you're applying rules, and so once you're in here, this is where we start applying filters and matching, or mediation logic, I'm sorry, before it works its way out of the fuser. Nice little pretty diagram showing the flow as everything goes through. So filtering rules, so we kind of slice in a couple different directions. You know, filtering for us, you could slice basically horizontally or vertically. I mean, if you're basically got data coming in and all you care about is Charlotte data, you could set up a filter that says, hey, I only want an airport that matches Charlotte. So as that data comes in, it's going to collapse down. You can also do attribute filtering, which is kind of, you know, vertically, where you're coming in, you're saying, well, I know there are these elements from this source, but they're never any good. They're garbage, or I just don't want them in my system. So there's basically a mechanism in the fuser that says, from this source, filter out these elements, and they just don't even get into the processing mix. They're filtered out as soon as they come in. There's other location filters, other things. You know, there's a number of varieties of filters, and these filters, you know, are all interface, so you can actually add additional ones. But the rules that we use, again, are documented. They're published on that Industry Day page, so it covers both the filtering and mediation rules that we're about to talk about. So mediation is basically now you can't filter because it's just gone. You can't filter either way, horizontal or vertically, but now you're in the mediation where you've got two things from two sources. Which do you trust? I mean, the easiest one, an example for me, is always the ETA. TFMS produces an ETA, but so does TBFM. So which ETA do you want? Well, we went through, you know, pretty good analysis to try to figure out which one we wanted to use, and we actually kind of learned that really ETA from TFMS is better pre-departure, but we were finding the ETA from TBFM is better post-departure. So we have a mediation rule that kind of is split out that way. And so we've had to build up a number of mediation rules, and for any airlines in here, I mean, if you were bringing the fuser into your own environment, and particularly if you're more, you know, IATA versus ICAO, you know, you're probably going to have more rules just dealing with trying to clean that kind of stuff up than maybe just straight up decision. So we've had mediation for a lot of IATA, ICAO stuff. We've had things for which flight plans to use, ETAs, gate information, which ones to trust there. Because we, you know, again, not necessarily in swim right now, but we're pulling in gates from, you know, a number of different sources, and we have different rules on which to trust. So that's where mediation comes in. You said there might have been a question in there.
Yeah, there's some questions about how we're actually applying these mediation rules. If we're using like a business rules engine, I guess, an off-the-shelf thing, or if it's more custom logic.
It is definitely custom, and so it's good timing on the question. So for us, the fuser, as I said, everything in that schema, you know, is pretty well defined. So you have the element, the type, and all that stuff, and then we basically have below that the fuser metadata. So the metadata for every element, we're tracking what source last updated it, the time it was last updated, and that's being stored under the hood. And so that's a key part. So that it's basically the mediation rules are. Skip forward just a little bit, but this is an example. This one's probably a little more involved example, but just kind of looking at the bottom, that it's just the XML that we're defining as to what a mediation rule is, and kind of for us, it's mostly which sources have what priority, and sometimes, you know, which secondary messages. So TFMS has like 18 different messages, so this is kind of saying, okay, this first list, you know, the priority is the messages on top, and then if you don't have those, you can go to the second one, and that one's a little more complex. Some of the others are just straight up favor TFMS over TBFM, or favor this one over this one, as a pretty simple example. But let me back up and walk you through this one a little bit. So we're capturing the metadata and bringing up the IATA ICAO. I mean, IATA, ICAO, and the FAA lookup ID. I mean, there's basically three flavors of an airport code, and we have this big lookup thing to kind of fill in whichever one we don't have. So there's like 27,000 of these, and so if we have IATA, we can look up the ICAO, and vice versa. It's not exactly one-to-one, and you know, but it gets you pretty close, and we're able to. And so we track all three of these. But you know, in this example, Doha, the code OTBD. That airport closed back in 2014 and was replaced by OTHH, but we still see messages that come out of TFMS, which are probably funneling in from some airline message into it most likely, but so we still see that one show up, but it wouldn't be such a problem if it were consistent, but we're seeing a mix, and then what would end up happening is things would just toggle back and forth, and that just throws things off. So we define a rule that says, okay, well, a flight plan amendment, these guys are pretty consistent. They're getting it right. The flight modify and a few of these other messages, they're the ones that are showing the bad data. So let's favor the flight plan amendments over the other ones, and so that's what we're defining there. And so when it ends up coming out of this is you say, oh, okay, I got, this first message, it was OTBD, which is basically in the OAG schedule, so that's really actually was not the correct one. And then later on we get the updates, and now we got basically filed flight plan, let's see, in this case, yeah, OTHH, and then we got the flight modify, which came in and tried to put it back to OTHH on that last message, but that rule would have said, hey, the flight plan amendment that we just got basically said we should be using OMDB, so stick with that. So that's kind of a more detailed case, not a straight up, but that's kind of how we dealt with that one. And all the mediation rules are listed on the Fuser site, but it is all custom stuff that we developed our own kind of rules engine, essentially, to kind of favor priority, favor sources over other sources.
There's a link to that Fuser site on your previous slide, is that right?
Yeah. Somewhere. That one at the bottom is the media. So, I mean, pretty much on that Industry Days link, it shows up a couple times in this presentation. There's all the documentation that's been put out from the Fuser related to some architecture stuff, some background on it, the data mappings, the mediation rules, filtering rules, all that stuff is out there. So. Alrighty. So, pretty much through. Now you're out of the Fuser, Fuser's pumping stuff out, so where does the data even go? Well, for us, it goes a number of places. We're holding it in memory, but for performance reasons, but we're putting it out to a Redis repository. This is our recovery piece. So Redis is a kind of an in-memory a database, but it also is persisting to disk, and it's really, really fast. But it's not really what I would say is great for analysis and querying capabilities, but it's been fantastic for that. So that's our recovery piece, pumping all the data out over ActiveMQ, and then all these guys in red are actually Fuser clients. So even our database loading process is a client of the Fuser. It's not embedded into the Fuser, our database loading. STBO is our surface trajectory-based operations side, so that's when you're getting to the client tools of ATD-2, so there's a bridge between the Fuser and that. And that's mainly because STBO existed before the Fuser. We had pieces of it that we were building on, so we built a bridge between those. And it, again, is a Fuser client API. We have a test tool that's a client API that we actually can interact with the Fuser. And really, there should be another cloud bubble. We'll talk about the Fuser in the cloud next, but it's spanning out to all kinds of different directions. Some quick other benefits we're not going to go in depth about, but I mean, it is doing full flight management, anything that needs to create a flight update. It has its own removal strategy. All this stuff is built into the Fuser, built-in recovery I talked about with our Redis. So I mean, you go down, or we're deploying a new build or whatever, we have to take it down, bring it back up. For us, we're back up. At least the Fuser is back up and running. Usually, definitely under a minute, but I would say around 30 seconds. But as you go bigger and bigger and bigger in the NAS, I mean that recovery time could go up a little bit more. We also have reconstitution built into the Fuser, so there's a sync service. So I mean, if you have one of these client APIs has to be restarted, not the whole Fuser, like our database loader. If we're restarting that process, it'll go and sync to the Fuser and say, hey, I need the full state of everything as it is right now, so that I can start building from there. And that's inherently built in. A lot of performance monitoring, and performance isn't just here's the number of messages coming out. We've kind of built in monitoring at a lot of different steps, down to millisecond ranges, so we can see how much time are we spending marshaling, how much time are we spending applying these mediation rules, how much time, things like that, trying to get to a really low level. So if we bottleneck in the Fuser, we want to be able to dig in as quick as possible, figure out what's bottlenecking us, and that's been in there for a while. And the architecture in general is pretty pluggable. I mean, all these rules that I've been talking about, it's basically some of it can be implemented in code, some of it can be implemented in XML, but there's a place that it could all be plugged in without necessarily having to go modify the core Fuser code to be able to do it.
Yeah, that reconstitution also encompasses the full universe of flights that we know about. It's not just limited to the past 6 hours or 2 hours.
Right.
It is everything that we know about in the system at that point in time.
Yeah, I mean, there is a point in time we're going to remove stuff, and we can't hold on to things forever. So, I mean, recovery, you're not getting everything. But usually we determine a flight's arrived and it's, not operating, I think after a few hours, we'll say, okay, that one's done. And flights that just never operate, eventually have to be removed to the system. So there's a removal strategy that shows up, and that's all distributed out too. For anybody that cares about the technology stack, so if you were going to try to use a Fuser in your organization, there's a lot of open source libraries in here. There's no getting around it. I'm not going to sugarcoat it. If your organization doesn't like open source stuff, then using even the Fuser client API might be a problem for you. At its core, it's Java. Apache Camel and the Spring Framework are pretty heavy in the core part of it, and then we get to the messaging aspects. We use a lot of ActiveMQ, Apache CXF for our sync service piece of it, and then I would consider this outer layer somewhat of the optional pieces, but pretty heavily used by us, and that's the Redis for the recovery piece, Postgres for our databases, and Drop Wizard is that metrics, that performance monitoring piece that we're kind of measuring, kind of down to some of the method level stuff. So there's each of those, probably has plenty of other libraries they're bringing in. We have a way of generating kind of all the libraries that are involved, but it's quite a bit of open source. But it's all, generally, as much as we can, we favor the Apache Commons 2 license. I mean, we're not using anything that's pure GPL, anything that really, no proprietary licenses that should restrict anybody, but not everybody is in favor about open source. All right, so let's see, time check. Oh, did awful, keep it on track. So Fuser in the cloud. So we have this idea of we wanted to make the Fuser available. So Al's like, hey, we want to start engaging with some partners, and we want to get them using the Fuser with the idea of preparing for tech transfer and knowing what it's like to try to get things both through a NASA process and then working with some other organizations, what it takes to get through their process. And I was talking on the open source stuff. It's a long uphill battle making things available and then getting it up in the organization. So we opted to try this Fuser in the cloud strategy where it's not as daunting for people to be able to consume something, out of the cloud, particularly, you just talk about messages versus having to set up, the full infrastructure themselves, and much less us trying to make it available. So this is, if you want to interact with the Fuser, this program that we're trying to work on is the fastest and easiest way, and quite honestly, at the moment, it is the only way, because we are working on ways to make Fuser code available, but that's really for the purposes of just so you understand the logic in it, not necessarily fully be able to run it in your own organization, because it's pretty I don't want to call it beastly, but I mean, it's pretty involved to get it all set up, configured, and get it all right, and understand it all. So, but consuming it, I think, is a much easier thing, and getting the value of all this stuff that we've already talked about going on is basically being implemented and being shared out this way. So, I present this roadmap, and if anybody was at Swift, you understand, it's not a linear thing. If you want to work with swim data and you're going to get to the end, it's not just do step 1, step 2, step 3, step 4, you're done. It's really kind of a cycle and interactive. You're gonna parse, you're gonna do some analysis, you're gonna store some stuff, you're gonna do some circles, and you're gonna go back around, you're gonna pick up another feed, and so on. But for the purpose of the presentation, it's a little easier just to say, hey, you're probably here, and I'm generalizing this. I'm sure some people in the room are just experts, and others maybe haven't even gotten started. But you're probably connected, you probably got some data, you're figuring out some of the parsing, and you're trying to figure out what you're going to do with it. So maybe that's where you're at right now with the swim data. If you were using the Fuser in the cloud, you could kind of jumpstart and go just skip past a bunch of the steps. It's already been parsed. It's already been kind of massaged together. It's it's gone through the analysis. It's been vetted, and so you could kind of start there, because you're probably goal in life is not, hey, I want to be able to parse swim data. Your goal is probably to make some kind of services or some decision support capability or provide some reporting capabilities or whatever it is. I mean, that's what you're after. So your goal is to get way up there to the services end. And Fuser in the cloud, you know, what we're proposing is this is a way just to get you closer there faster. So some of the benefits, this is probably true of most cloud applications. I mean, you're not basically investing as much in your IT infrastructure. You're not having to deal as much with the network and the IT, your hardware. You're basically going to something that's already set it up, done the heavy lifting for you, and you're bringing it in. Your maintenance cost, in theory goes down because you're letting that basically be handled by whoever's setting the stuff up in the cloud. For us, we're active and we're still trying to keep current. So as swim enhancement comes out, we're trying to stay ahead of them, make sure that those are baked into the Fuser. So, if you're using it, you're kind of getting it that way for free. The drawbacks, you're going to lose some of the control. I mean, we'd work with anybody to try to make it, fit their needs as much as possible, as long as it aligns with ATD-2 goals. But, you just don't have the same level of control that you would if you just rolled your own and set it up. But, it's going to take a while to get there. So it's a balance. But I think the pros heavily outweigh the cons at the moment, depending on where you're at in your life cycle. So for any techie guys or anybody that really cares, we're basically going to go from NASA, pipe it up, and we are piping up to AWS, kind of in a secure way. And then, it's on a private subnet, and then the public piece is fronted by elastic load balancers that, your organization, we would give you an IP address that only your organization is connecting into, and same thing for the other ones. So right now, and everybody's not coming in through the same IP. This allows us to kind of cut off any problems, any breaches or whatever, are kind of controlled at one point per person coming in or per organization, and these are kind of split out that way. But it's the same data that if we were running internal at NASA versus if I were running all up in the cloud or whatever, it's the same, whatever IP we ever have you connect to. It's the same full-fledged Fuser with all the work and heavy lifting done for you. So we got this pilot program, and Delta was our first partner, and I think after Swift last time, we've kind of presented the notion of the pilot. So we've got a few other interested parties, and we got United and American, Southwest, all engaging with the idea of, let's get them connected and try to see if this fits their needs. I don't know that, I know that there's a lot of work and a lot of time and a lot of great effort that's been put in this, and we believe there's value. But, the whole idea of the pilot program is to get it in and get some usage of it, or at least get them to try to work with it, see the data. Does it fit their needs? What's missing if not? And so we're really appreciative of those that have engaged with us, and we're working through that. Quite honestly, it's slow. There is no touching a firewall that doesn't take a while. So just getting the data into these organizations, they have to be allowed to connect to us in certain ports, and every organization is a little bit different process, but I can promise you they're all slow. So
yeah, to connect into any of the data right now, or to use any of the tools that we do have available for kind of more easily parsing this data, is there any licensing associated with that? Yep.
So you can connect to the Fuser. That's fine. That's fine. You can just with no restrictions whatsoever. Once you have the IP address and the access is allowed, you could just start consuming the XML data. Part of the benefit, I think, of the Fuser is the client API that comes with it, and that's, you wouldn't have to know how to parse the XML. And we are sending out deltas as well. So deltas meaning what's changed. So you would really kind of need to build up the full picture yourself. But the Fuser client API does all that for you. So, it'll do the connection. It'll manage the connection. It'll parse the XML. It'll build up the flight. It'll give you an in-memory repository. It'll write things out to CSV files that you want. It'll give you an ability to connect in. We are having a little bit of an issue, though, just making this available, because as I'm learning, as I'm going through all this, I'm a little new to it myself. Even just making this available from NASA has to go through a process. So working that one in parallel. So there are some that already have agreements with NASA for data sharing. So that makes it completely easy. We're working on other agreements where it's more generalized stuff that anybody can participate in Fuse in the Cloud when they assign these agreements. It's all taking a little time, but we're working 3-4 different avenues to make this all possible, to make it as easy as possible for people to get connected, be able to share this data. So, so the answer to the question, Brian, I mean, it's open source stuff, so that is for your organization, but there is a little bit of a holdup with some folks that don't have any agreements in place right now with NASA on making the Fuser Client API available. The XML part, just consuming that, is not restricted from that angle. So we talked about the Fuser Client API, just kind of hit on all the points of that. And so, but this, all right, so I wish I created more diagrams for this, and I do want to hammer this one, though. Like, for using the Fuser, you could use it like ATD-2. I mean, it is the backbone of ATD-2. I mean, it does all the heavy lifting. It is our recovery piece. It is what's feeding our STBO application. I mean, if the Fuser dies, all of ATD-2 is down. I mean, there is, nothing's moving. It just stops. So it's a good thing that it's, it's pretty stable and tolerant and everything, but it doesn't have to be your backbone. It could just be as simple as just be another feed for you, but an easier feed to work with. It's got the TFMS data in there. It's got the TBFM data, and we've already made the code changes to put the TTP data in it. So, I think TTP is going to have a lot of value to people when it comes along, but it's another feed that you need to know how to parse. It's going to be available at a lot of different airports. You would have to learn how to blend the data together yourself. It's in the Fuser. You could just consider using the Fuser as a feed by itself, just so that it's kind of more one-stop shopping of swim data. Each message tells you what source it came from. Each message is pretty well, pretty well documented. So I mean, that's a possibility. And then you could take that and blend it into your own data however you see fit. Whereas right now you're probably taking some, doing what we're doing, the Fuser. You're taking pieces from TFMS, taking pieces from TBFM, so on and so forth, and you happen to blend all those pieces in. So, definitely something to consider if you're considering, trying to learn more about the Fuser, engage with the Fuser. You seem a little restless. Oh. So I only got one more slide left, so let me just wrap up. So I hinted on the challenges, and they basically come in 3 flavors. One, the networking stuff. The second one is just being able to share the CDM data. We're working on agreements and process to make sure that, particularly for the airlines that are engaging, to make sure that when we rebroadcast the data from the Fuser, that we can share the CDM data back to them. So right now, there are definitely restrictions that we're dealing with. So all these things are moving in parallel. We're working hard with the industry partners and NASA to try to come up with ways around all of this stuff. And again, so this isn't the end of it, though. I mean, Fuser in the Cloud is the backbone of ATD-2, but we're trying to make this available. But we don't want to stop there. There's services, there's other added value stuff that we want to look towards, and so we want to work with you guys to get there. And so. I'm sorry, I really thought I would get through this a lot smoother today, but if anybody wants to stick around and ask questions before you reach the other session, I'll be around all day. I'll be here for the after-hours stuff, so anybody has any questions, feel free to grab me, Brian, anybody on the ATD-2 team, and thank you for your time.
Yep. If I, I'm sorry, if I could just have one more minute. I've been punting on this question. There's been several comments on it throughout the thing. It was just whether or not TFDM will be using the Fuser and using the similar matching logic, if we know the answer to that.
TFDM will have their own Fuse setup. They're not using our Fuser. They're going to have to do something similar because they are ingesting data from those sources and other sources, so they're going to have their own backbone architecture. They're not using our Fuser. Josh is in the back of the room. I'm going to put him on the spot. If anybody wants to stop by and ask Josh, like, hey, is there some avenue in the FAA for the Fuser, and like, where's it going after this? Let's keep Josh in that corner up there and see if maybe we can have that discussion, because I know that has come up a number of times from people outside this, and I don't have that answer. So maybe Josh doesn't either, but we can. So, all right. Thanks again, everybody.